Hello again. We're here to bring you our third update on how our 62 kilowatt hour Nissan Leaf is faring connected to vehicle to grid. We have chosen this time because it's exactly 1 year ago that we took delivery of our new Leaf. So after 8,781 miles and 290 days connected to vehicle to grid, has the car prospered or suffered? Are we pleased or unhappy with this great experiment? And of course, have we made or lost money? We left Fish Brothers in Swindon on the 15th of August 2019 with the new car. Before we even went home, we drove directly to Indra in Great Malvern, where Mike Schooling and his talented team, who designed the vehicle to grid charger, were waiting to try it out on a 62 kilowatt hour Leaf for the first time. On the 1st of November, the V2G installation was completed, and of course you can watch our video all about that. We made another video in February that included some rather vague results, but since then the car has always been connected to the grid via the V2G system when at home. On the 16th of March, we drove from Worcester to Darwin Forest in Derbyshire to see family, and while we were there, Boris announced a ban on all driving except for essential journeys. For quite a while after this, our car travelled just 2 miles per week. That's the distance to our local Tesco and back. You may remember we had previously set Kaluza to have the car charged to 90% by 9 AM every day. By the first Friday of lockdown, we realised it would be sensible to change this. We reset the Kaluza app to always retain 35%, but not charge higher than 70%. Most importantly though, we abandoned altogether our ready buy requirement. A spread of 35% to 70% seemed reasonable, and our thinking was if the car was going to be idle, we would rather have the battery being charged and discharged a reasonable amount every day, rather than sitting here, say at 60% for a week after week. There was no scientific reasoning behind this, it just seemed like a sensible thing to do. So, in effect, we gave the grid 22 kilowatt hours of battery to play with as and whenever it wished. The effect was immediate and dramatic. Let's see what happened. Here are two typical charge-discharge graphs from just before we changed things. Charging the car in the early hours to reach 90% by 9 AM. And discharging to support the grid from around 4 PM, tailing off around 10 PM. Now compare these two example days. Although we allowed the grid to use 22 kilowatt hours of our battery's 62 kilowatt hour capacity, on Saturday the 28th, the car took 31.6 kilowatt hours from the grid and sent 25.6 kilowatt hours back. In other words, that 22 kilowatt hours was used more than once during each 24-hour period. 35% of our battery was obviously plenty, and we felt it kept the charge-discharge range within sensible limits for a car that was essentially otherwise sitting idle. When we know that we will need the car for a longer trip next day, we simply hit the boost button in the app or on the machine around 10 PM and we wake up to 100% charge the following morning. This has worked out so well, we don't have any plans to return to our original 90% by 9 AM every day. The grid certainly likes it, and it works for us. However, does the car like it? One of the most common questions we're asked is what has happened to our car's battery since we've had vehicle to grid. So let's find out. We'll start by calculating the totals for V2G and our travel over the last 12 months. The odometer shows the car travelled 8,781 miles. Drive Computer 2, which we zeroed when we received the vehicle, says we averaged 3.5 miles per kilowatt hour over the year, and the energy economy gauge says 3.4. The simple sum, 8,781 divided by 3.5, tells us we used around 2,500 kilowatt hours by travelling. How does this compare with the electricity the battery has used in vehicle to grid since last November? We added up all the totals reported by the Kaluza app since we've had vehicle to grid. We discovered the car has imported a total of 5,261 kilowatt hours and exported a total of 3,297 to the grid. Vehicle to grid has used over twice the battery capacity that we've used in driving, and most of that has been while allowing only 35% of our battery capacity to be used. So the next obvious question is, how has the battery coped with this? Let's look at the data. Here's a screenshot of the battery condition taken with LeafSpy Pro on 29th of August last year. The important figure here is the battery state of health, SOH, which was at 99.38%. We see the same figure in this details screen. Below that is this one, which says the battery health is 107.19%, whatever that means. Let's compare these with today's figures almost exactly a year later. We see a state of health of 97.76%, a drop of 1.62%. In the same period, the battery health figure in the details screen shows us an increase from last year's 107 to 112%. Let's be honest, we have no idea what that battery health figure means. If you know, leave a comment below and enlighten us all. But what is clear is that during the past year, we appear to have lost maybe 1.6% of our battery capacity. This equates to 3-point-something miles of our 230-mile range. Being 1 year old, the vehicle has had its first service last week. Let's have a look at the battery report. We'd expect no less, especially with a state of health of 97.76%. And of course the car's own battery capacity gauge shows full. By the way, the sharp-eyed amongst you might have spotted the odometer in the car does not match the number reported by LeafSpy. We have no idea why they differ. Again, if you know, pop a comment in the box below. While we're looking at the LeafSpy stats, let's notice something else as well. We reckon we've charged on a rapid charger no more than 15 times since we've had the car. How come the stats show 278 quick charges and only 62 level 1 or level 2 charges? Vehicle to grid uses the CHAdeMO connector, yet it only delivers 6 kilowatts of power to the car. It's obviously either plugging this in or perhaps delivering a DC charge that the car counts as a quick charge, not the actual power. Is this why the Advice for Your Usage section of the Servicing Battery Report cites frequent use of quick charging as a cause of gradual loss of capacity? And if so, why does it go on to recommend your score is very high and good for your battery? Okay, we find all this fascinating, but equally interesting is the money. You may remember back in February we were finding it really difficult to make much sense of what was happening financially. Large gaps in our February usage graph meant we had to have a correction in March. This shows us a balance adjustment of £82.95. However, in April, OVO changed its corporate mind and refunded it again. So once more, we're left a little bemused to say the least. Remember, we have solar panels, so these figures take those into account as well as vehicle to grid. The headline news, though, is that from April onwards, we have made an overall profit on our energy bills every month. Pause the video and examine our figures as much as you like. You will notice this is all our energy, including our gas, which we use for heating in the winter, cooking and hot water all year. Obviously 2020 has been an odd year, and from here on it's a gentle slope downwards towards winter. But given that OVO's accounting is improving, we hope to see an understandable, smooth transition into the winter months when days shorten and we use more electricity and gas. So far though, we're not complaining. We may well return in the new year and give you an update on our first full year of vehicle to grid. Thank you for watching. And thank you for all the many really interesting comments and questions on our previous videos. We do answer every one, so don't be shy. If you have a question, type away. Please do all the usual stuff, like, comment, subscribe, hit that notification bell, and we'll see you next time.